Alright, welcome. In this video, I'm going to be working AP Pre-Cal Homework 9.2, which is all about the graphs of secant, cosecant, and cotangent. And so we're going to start off by just, graphing one period of y equals sine x and its reciprocal and doing the same thing with cosine. So what I'm going to do, I'm going to just sketch the graph of y equals sine x, and then I will sketch the graph of the reciprocal kind of on top of it, is what I'm thinking. So, remembering that, y equals sine x starts in the middle, goes up, then comes back down, and then eventually recovers back to the middle. We've done this a few times. Sketching the graph of y equals sine x in red, and this is really not, I don't think I measured out a quarter of the way all that well. Oh, that'll get the job done, right? And so I think what we usually did at this point was said sine x plus is 0, so the midline's 0, amplitude's 1, and, there's no phase shift, so, okay, this is x equals 0, it's the y-axis. The x-axis is going to run through there, approximately, and I'll call that x. And, all right, now we're pretty much ready to, graph the reciprocal. Great. Okay, so at this point, what I would say is that the zeros of sine become vertical asymptotes on the graph of cosecant. So I'm going to say, all right, well, to switch it up to cosecant is going to be in blue. I'm going to have vertical asymptote through here because that's a zero of sine. And the zeros of sine will correspond to the vertical asymptotes of cosecant because cosecant is 1 over sine. And we know that the cause of a vertical asymptote is division by 0. We've seen that in this class before. Okay, so I'm going in, I'm labeling these vertical asymptotes, and I think at this point maybe actually I should hold on to the graph of the original because we are going to see, all right, well, 1 divided by 1 is 1, so the points at the extremes are kind of like the shared points on the graph, and so I'll be able to, get rid of that part of the graph. It's supposed to be point right there. And then on the other side, okay, this is the shared point at that extreme because 1 over negative 1 is still negative 1. Okay, just going to draw those parts of the graph and then we'll just call it from there. All right, that's going to be one period of cosecant, right? Okay, so if we wanted to do the same thing on cosine and secant, it's going to look pretty much exactly the same. So I'm thinking maybe on this one I can do a little better. Okay, so I'm going to sketch the graph of cosine. Okay, just about like that. And let's see. Okay, I think I'm going to bring in the axes from here. Okay, so that'll be x. And what am I saying here? Okay, the zeros become the vertical asymptotes, so I'm going to just kind of say, all right, that is a vertical asymptote here. And then, okay, the shared points, probably be the next place to go. Okay, let's be up there. I'm going to just go ahead and draw the rest of the graph because we saw in class what these look like. We know this is a bunch of u's, so I can just keep drawing, right? There's nothing wrong with that. And then I'll just go and get rid of cosine x, so I'm only looking at the graph of y equals secant x. There it is. I guess I could probably make this a little bit better by extending the y-axis. And there you go. And if you want to make it look really nice, you could get rid of the original window, and then there you have it. Okay, but I feel like that kind of loses some of the meaning because we remember, okay, with the window, the standard height is 1 and negative 1. So, all right, there we go. We've sketched a graph of one period of each of these things and the reciprocals. Okay, now for tangent, I don't want this to be too crowded or confusing or whatever, so I'm going to actually draw them separately. So y equals tangent x. I think I like to draw the y-axis in the center, but this actually feels like maybe not exactly halfway. That looks good. And then I will, okay, so it's probably, yep, that looks good to me. Okay, it's going to be my x-axis. I can't remember, this might end up being 2 periods of y equals tangent x. But what I would say, what I want to remind you about y equals tangent x is negative pi over 2 and pi over 2 are kind of the 2 standard vertical asymptotes, or the first 2 that we would encounter as we move away from x equals 0. And so for y equals tangent x, which I'm going to sketch in red, we've got these vertical asymptotes here. And then the graph of y equals tangent x itself, it's the one that's got the arms, and it's going up there. We have a point of inflection at the zeros, so it's going to come from below, increase. Okay, there would be an inflection point there. This is going to be, I think, 3 full periods, but it's all right. You can see what I'm saying. Okay, there we go. Not my best sketch of y equals tangent x ever, but it's pretty good. All right, then for cotangent x, I'm thinking I'm going to do a little copy pasting here. Okay, now for cotangent x, just like with secant and cosecant, the zeros of y equals tangent x will become vertical asymptotes on y equals cotangent x. Okay, so I'm going to have a vertical asymptote here, a vertical asymptote there. And you may have noticed that the vertical asymptotes for y equals cotangent x are the same as the vertical asymptotes for y equals cosecant x. And that would be, and I didn't really address that. I had somebody mention it. I was like, oh, yeah, definitely. And I think I maybe addressed it with them individually, but I didn't tell the whole group. But what I would say is that because cotangent theta is equal to cosine theta over sine theta, and also cosecant theta is equal to 1 over sine theta. Okay, we're going to have vertical asymptotes at the same place because we know the cos of a vertical asymptote is division by 0, so it's all the places where sine theta could equal 0 on the unit circle. Okay, now, I think what I showed you in class and what I would point out again is that the arms of cotangent, they go downhill. And I think a good reason for why, but even before we get to that, the vertical asymptotes of tangent are going to become the zeros of cotangent. Not because 1 over infinity is equal to 0, because it certainly is not. Okay, that's the type of thing that, maybe not for AP Precal, but in other classes, in something like 1 over infinity equals 0, that's a sure way to lose all of the credit you've earned up to that point. So we don't want to be doing arithmetic with infinity. I think the better way is to say, okay, for instance, theta equals pi over 2. Just hoping for the best with that. Yeah, great. Up here, the x-coordinate is 0 and the y-coordinate is 1. Okay, cotangent is cosine divided by sine. It's the x-coordinate of the intersection point divided by the y-coordinate of the intersection point, between the unit circle and the terminal ray of my angle. Okay, so cotangent of pi over 2 is 0 divided by 1, which is 0. Okay, so that's probably the better reason than thinking about infinities and stuff. Just going back to the unit circle. Now, between negative pi over 2 and 0, for instance, I'm talking about right there on the graph of y equals tangent x, tangent is negative, and 1 over a negative number is still going to be negative, so that's why we're seeing it negative and approaching that vertical asymptote. And then, we know that the graph of tangent is repetitive like that, so it makes a lot of sense that the graph of cotangent would also be repetitive. But that's more than one period if y equals tangent x and it's reciprocal. Okay, now we're going to sketch a graph of a transformed reciprocal function. So like 2 cosecant of half x plus 3. And so what we're going to do for one like this is we're going to think to ourselves, well, like really, we're going to sketch the graph of y equals 2 sine. Because sine and cosecant are reciprocals, we're going to start with that graph and then do the exact same thing we did in class to generate the standard graphs. All right, so sine starts in the middle and then kind of goes up, but that I should probably mark what I think is halfway so that I can try to make this look a little bit better. That is significantly better. All right, so, and then there was no phase shift, so we're starting here at x equals 0. The period equals 2 pi divided by b, which in this case is 1 over 2, because it's x divided by 2. And that's going to equal 4 pi. So I'm going to add 4 pi to get to the right edge of the window. And then that should be in my, I think that's good enough to determine, we need to find the domain, figure out what the vertical asymptotes are. We're going to have 3 of them, so I think that should show you the pattern. Okay, that does mean that 2 pi is in the middle, and this is 1 pi and 3 pi. I don't know if that'll be useful. Okay, the midline is going to be 3, because we're adding 3 on the outside, and then the amplitude of y equals 2 sine of theta plus 3, that's going to be 2. So go up 2 and down 2, and now I've got kind of the skeleton ready. Now what I'm going to do is say, all right, the zeros of, or what had been the zeros of sine before these transforms will become vertical asymptotes. So it'll be here and there, and one over here as well. Then the shared points are going to look like that. Okay, starting at the shared point, drawing the u's. Okay, I'll get rid of this graph because this is not part of the graph. Okay, f of x is 2 cosecant. Okay, so I've got my y-axis coming through here. Okay, and then the x-axis will be, I don't know, somewhere about like that. That looks good to me. And there you go. That's a perfectly decent sketch of the graph of f of x. What are the domain and range of f? Okay, well, for the domain, I'm going to say, it'll be easier to say what x is not allowed to equal. So x is not allowed to equal 0, 2 pi, 4 pi, looks like 6 pi or 8 pi either. So I'm going to say x is not equal to 2 pi n, where n is an integer. Okay, and then for the range, I think it's a little easier to see from the diagram. We're either at or above 5 or at or below 1. So at or above 5 or at or below 1. That'll be the domain and range of f. Okay, now we're going to sketch the graph of g of x. What are the domain and range of g? Okay, well, we're going to start by graphing y equals 4 cosine of pi times x minus 1. And add 3. Okay, so that's got all the moving parts. So I'm going to draw this one. I figured if I made the box a little taller, maybe my graph wouldn't look as bad. I think a lot of it has to do with me making sure I get that halfway point just right, which I think will be right there. Draw the midline. Cosine's the one that starts at the top and goes down. That's a little too vertical. That will be like it. All right, so that's one period of cosine. Okay, we've got a phase shift of 1 because we subtracted 1 on the inside. It's our horizontal translation. Okay, the period is going to equal 2 pi divided by b, which is the multiplier in the front, so or in the front of the x, pardon me. And so it's 2 pi divided by pi, that's going to be 2. So I'd add 2 to 1 and get 3. Halfway between 1 and 3 is going to be 2. So that'd be 1.5 and 2.5 there. I don't know if we're going to need that, but if we do, we'll have it ready. So the midline was 3. Amplitude was 4. And so I've kind of got all the pieces I need. Okay? The zeros of cosine, or the zeros of cosine before all of the translation and dilation and stuff, those will correspond to the vertical asymptotes on... Well, were these both... Okay, I just assumed that this was going to be secant because the last one was cosecant. I figured we'd want to sketch both of them. It's all good, and we're going to have to get rid of all of this, though. I think the period and the phase shift and the midline and the amplitude, that work is still valid. I just kind of started off, and need to start off with not 4 cosine, but 4 sine. Just didn't even read the problem. Just assumed. All right, so 4 sine is going to start in the middle, eventually go back to the middle. I'll need to get rid of that point. That will not be part of my graph. And then eventually recover back to there. About like that. All right. And then, okay, now we're happy. We've got a graph of y equals 4 sine of pi times x minus 1, and then add 3. So the zeros of sine are going to become the vertical asymptotes on this graph. Okay, and then what else do I need? Okay, I'd probably draw in the u's. Okay. And then, I think that's probably good enough for our purposes, but if you wanted to make this look extra nice and draw your axes, then I would have a y-axis over here. Yeah, because we're starting off at x equals 1. And then the x-axis would be somewhere between -1 and 3. I think that's a good location there. And that'll be, at least part of the graph, 1 period. Okay. Now, this one is secant. I did not find the domain and range of G, but I can do that right now. All right, so for G, the domain, X is not going to be able to equal anything where I've got a vertical asymptote. 1, 2, 3. You could call that 1 plus n, where n is an integer. Or you could just call that n, where n is an integer, because we're also going to have a vertical asymptote. I didn't draw this very well to scale. We're going to have another asymptote at x equals 0. Okay, then the range. I would say that in y, I'm either greater than or equal to 7. That's that first u that I found. Or I am less than or equal to -1. Okay, with that second u. And then, yeah, that's it, domain and range. All right, I was already thinking about the next two. All right, these are both secant, so at least I'll be ready for those. Those are based off the graph of cosine. I'm going to start with the graph of cosine. All right, there we go. And, okay, phase shift was 0. I didn't have any horizontal translation. Period is going to equal 2 pi divided by b, which in this case is 4, so it's pi over 2. Halfway between 0 and pi over 2 would be pi over 4. Halfway between 0 and pi over 4 would be pi divided by 8. 1/8, 1/4 is 2/8. This will be 3/8 of pi. I don't know that that will be necessary, but this is the type of thing that we struggle with when we were learning about trig graphs in the first place, so I figured I'd just reinforce it here. All right, we're subtracting 4, so the midline is -4, amplitude's 3, so I can go down to -7 or up to -1. Okay, and because this is secant, really secant or cosecant, I know that the zeros of the original parent function are going to become the vertical asymptotes over here. And let's see, and from there I'm just going to draw these. Oof. Not my best sketches ever, but that's not the point here. So get rid of all of that. Think about where my x-axis and y-axis will be. Okay, that'll be a y-axis. X-axis would be above y equals -1, so that would be over here maybe. Call that the x-axis, and then I'm ready to write down the domain and range. All right, so domain. Okay, x is not going to be able to equal pi over 8. And it looks like the separation between these vertical asymptotes is going to be pi over 4. I can see that from the diagram. You can think about what do you add to pi over 8 to get 3 pi over 8. Either way, it's a width of pi over 4. So plus pi over 4n, where n is an integer. And then the range, I'm going to say y is greater than or equal to -1, or also y is less than or equal to -7. But y is not going to be able to equal anything between -7 and -1 because, as you can see, there's no graph inside that window. No red graph. There had been cosine graph in there, but this is a secant graph. All right, now last one, j of x equals 4 secant of 2 times x minus pi over 4. All right, domain and range of j of x. And let's see, 0, 4, and -4. All right, so I've got a phase shift pi over 4. I guess I'm labeling first. Period equals 2 pi divided by b, which in this case is 2. So it'll be 1 pi, so pi plus pi over 4. That's the type of thing we have a lot of practice on. 5 pi over 4. Halfway in the middle between pi over 4 and 5 pi over 4. Add them together, get 6 pi over 4 divided in half. That's 3 pi over 4. Okay, so that's 1 pi over 4, 2 pi over 4, 3 pi over 4. Okay, this will be 4 pi over 4. All right, there we go. Labeled everything. And, all right, so if I'm eventually trying to graph secant, I need to start with cosine. Okay, and there we have it. Now, if I'm interested in graphing secant, I come in first with the vertical asymptotes, which correspond to the zeros on the graph of cosine, the original zeros. And then, okay, go to the shared points, draw the little u's. Let's see, there will be another one over here, and one down here as well. All right. And then I guess lastly, I'll get rid of the original graph and draw myself x and y axes. Okay, that one went good. Let's see, where would the y-axis be? It would be to the left of pi over 4. And so, because pi over 4 is a positive number. Okay, so there we go. That's, oh, nope, not done. Domain and range. All right, in this case, domain pi over 2 pi. So this is going to be pi over 2 plus pi n, where n is an integer. Pi over 2 pi, 3 pi over 2, 2 pi, negative pi over 2, probably 0. No, negative, no, 0, that one didn't work. Negative pi over 2, I definitely didn't draw that interacting with the y-axis quite right. But again, we really don't care about your sketches of these. The problems here are going to be more important for us, where we're like actually reasoning with the functions. So find the vertical asymptote locations of the function f of x equals cotangent 2x. All right, well, actually, let me just draw the circle and say, all right, cotangent fails to exist anywhere sine of theta is equal to 0. So it will be here and there. So kind of my normal cotangent vertical asymptotes are x equals pi times n, where n is an integer. But, okay, when we multiply by 2 on x on the inside of the function, that's going to be a horizontal dilation by a factor of 1/2. I might even add that in. Okay. So I would say x equals half of pi n, so we could call that pi over 2n. Now, it wouldn't be pi over 2 times n over 2, because that would be multiplying by half twice, which would really be like multiplying by a fourth. X equals pi over 2n, where n is an integer. Now, if you wanted to solve this problem by like actually sketching the graph of cotangent 2x and going from there, that's an option you have, but I just don't think that's going to be the way to go, at least for me. That doesn't seem like the most obvious way. All right, state the vertical asymptote locations of the function f of x equals negative cotangent of 4x. Well, the negative isn't going to really do anything. Oh, increasing or decreasing over its domain. Forgot about that. Okay, now a standard cotangent graph goes decreasing, right? Its arms go downhill. So I'm going to say it's decreasing. And, if you're unsure about that, maybe you just go pull up a Desmos window, on whatever device you're watching this video on, and just go graph y equals cotangent 2x, and you'll see what I'm saying, that the arms, as you move left to right, they go down. But negative cotangent of 4x, okay, they would be, vertically reflected across the x-axis. It will actually look kind of like saying like a regular tangent graph. So the standard vertical asymptotes for a cotangent function are x equals pi n, where n is an integer. For us, we're going to again horizontally dilate by a factor of 1 over 4. So I'm going to say really my vertical asymptotes are pi over 4 times n, where n is any integer. And this one, because of the negative multiplier, I am going to say that this one's increasing. Okay, write an expression for all of the vertical asymptotes. Did we not just do that one? Yeah. I'm going to just go ahead and decline to do F because we just did that. That was number 8. Okay, vertical asymptotes here are going to be all right. Well, let me think about this. Okay, yeah, with secant and cosecant, especially one like this, where I think this one, I think I probably meant to put a multiplier of pi or something in front of the x minus 3, but I did not, and so we're just going to work this one as we see it. And so I'm going to go over here and just produce a real quick sketch of the graph of cosine. Oh, that was really bad. Do better than that. Okay, that's about as good as I can do right now. Okay, and so we say the phase shift is 3, the period, there's no multiplier, so it's going to be 2 pi, so that'll be 3 plus 2 pi, and it's like, wait a minute. Oh, no. Okay, but, halfway in between would be 3 plus 1 pi, and that's going to be 3 plus pi over 2. And these are the things that eventually, that'd be plus 3 pi over 2, and you can't even read that. I thought maybe that would help, but it didn't really help all that much. And all that to say, okay, here's where the, kind of the original zeros on the y equals 2 cosine of x minus 3 sit. And without thinking about the plus 4 or whatever, these are going to be the locations of the vertical asymptotes on g of x. So what I'm going to say is it's 3 plus pi over 2 and 3 plus 3 pi over 2. I'm going to take the same approach I have been taking, which is to say, all right, it's x equals, just grab the first one you see, 3 plus pi over 2. And then plus the distance here looks to me like we're adding a pi. So plus pi n, where n is an integer. Okay, that was just a particularly weird answer. Okay, for 4 cosecant 3x minus 2, I'm going to graph y equals 4 sine of 3x minus 2, and then just think about where the vertical asymptotes are and try to get an expression for, or vertical asymptotes for h are, and then get an expression for all of them. All right, that looks like that's right in the middle, and here we've got one, some there, there we go. All right, sine starts in the middle going uphill. And no phase shift. Multiplier is 3, period is 2 pi over 3. Okay, so this would be 1 pi over 3. Half of pi over 3 is pi over 6. I don't think I'm going to actually need these because the points I'm looking for are here and there and there. Okay, so that's 0, pi over 3, and 2 pi over 3. So that's going to be 0 plus pi over 3n, where n is any integer, or we could just say x equals pi over 3n, where n is an element of the set of integers. Okay, and then 3 cotangent of x minus pi over 4. The other ones I had remembered that for cotangent, the vertical asymptotes were x equals pi times n. Okay, for know if I did a good enough job of emphasizing that. That's just for cotangent of regular x. So if I replace x with x minus pi over 4, I'd have x minus pi over 4 equals pi n for my asymptotes. That would be, what is that, j of x. Okay, and then we're just going to add pi over 4 to both sides and say, all right, x equals pi over 4 plus pi n. But that's really what we're doing when we say, oh, well, x minus pi over 4, replacing x with that is going to shift the graph of cotangent right pi over 4 units. That's exactly what we're saying here. All right, so here we've got it. X equals pi over 4 plus pi n. Those are the locations of the vertical asymptotes on the graph of the function. We're ready to move on. All right, so we're on to the last page, and this is one where I'll just jump in front of it right now and say that there is more than one correct answer for these graphs, right? There's more than one type of equation that could work. For me, I'm going to go with the most obvious and the one that would require the least amount of phase shifting, okay? So if I have, basically what I'm saying is if the y-axis is not a vertical asymptote, I know I'm looking at the graph of a secant type function. Because cosine of 0 equals 1, whereas sine of 0 equals 0. So if it was cosecant, at theta equals 0, sine of 0 is 0, cosecant doesn't exist. So I'd be seeing a vertical asymptote on the y-axis where x equals 0 if I had a graph of cosecant. So I'm going to say it's some number of secant of something. Now, the middle does appear to be the x-axis, so I do think that's going to be 0. But I think really what you're going to have to do is think about the graph of the underlying sine or cosine, and then just kind of be like, okay, it's going to go up like that, and then all right, that's as good as I got. Okay, and what I'm saying here is that this thing appears to have an amplitude of 2. And let's think about the period. Looks like the period's 1.5. Or I guess it would be 3. All right, now I don't know if the period of this thing is pi or if it's not. I'm really not going to be able to tell. I'm just going to assume the period is 3 based on what I can see. And so I'm going to say, all right, well, if the period equals 2 pi divided by b, and then 3b equals 2 pi, and that'll mean b is 2 pi over 3. Okay, so 2 pi over 3, and I'm just going to assume no phase shift. That's why I chose secant in the first place. So there we go. That's what I think the graph is. But it could have been 2 pi over pi, just 2x, and I probably would not be able to see the difference. Okay, this one, what's the difference? This one looks very similar to me, but okay, obviously the vertical asymptotes are in a different location. I'm seeing it, this 2 and -2 right here. So I'm thinking, again, y equals 2 secant of something. And doesn't look like there's been a vertical translation, because it does look like it's very centered around the x-axis. So, all right, I don't really know. What is the period supposed to be here? What would be a little bit less than 1? Pi over 4. I bet that's what that... I bet I've got pi over 4 here and negative pi over 4 there. So I'm going to just assume that the period is pi over 2. I remember when we were thinking about these graphs, and I just don't think we really were thinking about how to figure out the period. Yeah, I don't really... If I'm missing something, feel free to comment on this video or bring it to me sometime before school. Period is equal to pi over 2. Period equals 2 pi divided by b. So b needs to equal 4. And I don't think, I'm not going to be doing any phase shifting because this one I've got that u that's centered around the y-axis. The y-axis is not a vertical asymptote, so I just think it's secant. Okay. This is one that has vertical asymptote of y, like the y-axis is a vertical asymptote, so I'm going to assume I've got y equals some number of cosecants. But again, it does appear to me that I've got my graph kind of centered around the x-axis, so I don't think I'll be adding anything on the outside. Okay, once again, I think the amplitude of the underlying sinusoidal function is going to be 2. So because of this, I'm going to say 2 cosecant. And then I'm going to be thinking about the period. All right, on this one, the period is exactly 3. I am certain about that. Period equals 3 because, 0, 3, 6, 9, -3, -6. That means okay, B is going to equal 2 pi over 3 once again. And yeah, no phase shift. Assuming best case scenario. That's why I said this is probably the graph of cosecant. All right, that's all. Yeah, this lesson, kind of like the last one, this is not going to be the most important thing ever in AP Pre-Cal. At the most, you're kind of doing this, like choosing from a lineup which is the right graph or which is the right equation for a given graph. So, it's not supposed to be the most stressful experience ever, and we don't need to be really pulling our hair out over the graphs, sketching the graphs of these things, right? I don't have enough hair left to do that. So that's going to be all for this video. Thanks for watching. That's what I'm saying.